Duong and my friend Dat. We come from Yagi group. So today we'll represent about the topic Open Neural Network Exchange Runtime. My presentation is divided into 4 parts. Introduce about Open Neural Network Exchange. Introduce about ONNS runtime. ORT become the most popular engine. And the last is conclusion. So we go to part 1. Introduce about Open Neural Network Exchange. ONNS stands for Open Neural Network Exchange and serves as a common intermediate representation that facilitates as a conversion of machine learning model across various frameworks including ONNS format. This enables easier model transfer between different frameworks. ONNS support conversion between many popular frameworks today, such as Keras, TensorFlow, Scikit-learn, PyTorch, and XGBoost.
So, what makes ONNS capable of achieving this? The first, standardized computational graph representation. Each framework has its own methods of representing computational graph. ONNS provides a standardized graph representation through multiple computational nodes, allow it to represent the graph of frameworks. The second, standardized data types. ONNS offers standardized data types including InS, InCT, velocity, and etc. The third, standardized functions. ONNS provides functions that can be mapped to equivalent functions in the desired framework. For example, the softmax function in PyTorch will be appropriately converted to the corresponding softmax function in ONNS. ONNS supports two types of conversion. Choice-based. In this method, the model is provided with an input and the model is disaggregated. The function used during this process are traced and recorded. A notable caution here is that if the model is dynamic, meaning it uses different functions depending on the input data, then the model after conversion may not function correctly. Script-based. In this form, the model is supported as a script model.
We go to part 2. Introduce about ONNS runtime. ORT as a runtime engine runs the ONNS model on different hardware. This possibility can be done through the APIs provided by ONNS runtime itself. In other words, execution providers are hardware acceleration interface for acquiring the capability of that hardware. Among runtime engines, ONNS runtime is one of the most well-known accelerators. This can be used for both model training and inference. So we go to next part. Why ORT becomes the most popular engine and widely used in the world. We research and quantify 7 reasons that graph optimization, support for multiple hardware accelerators, runtime optimization, dynamic conversion with precision cost, minimizing memory cost and efficient resource management, cross-framework and format compatibility, And last is continuous updates and community support. We go to graph optimization. Our next runtime apply various automatic optimization techniques to the computational graph of ONX model. The computational graph represents the operation and data within the model. The optimizations have minimized the number of operations needed, merge operator, and eliminate unnecessary components. In this topic, we will introduce 3 types of optimization. We go to folded. This method works with consecutive operator to reduce the number of computation steps. Example, suppose there are consecutive addition operations in a model like sum of A, S, B, then SC. So we can reduce that into one step, that A, S, B, and SC. Similarly, constant regression can be recomputed, so the model doesn't repeatedly calculate the same result. Elimination, removing unnecessary operator or computational nodes that do not contribute to the final result. Example, consider a situation where model compute an intermediate value that may be used for final output. Elimination with removing computation, reducing unnecessary work. And third is fusion. This method combining multiple operators into more complex operators that require fewer computation steps, such as merging multiple convolution and activation layers. Example, in a neural network, instead of performing a separate convolution, back normalization and activation function in multiple steps, they can be filled into a single operation, making execution faster and reduce memory asset.
Choose support for multiple hardware accelerators. ONX runtime can leverage various hardware types, including GPU, CPUs, GPUs, and other hardware accelerators such as TensorRT, OpenVINO, DirectML, and FPGA device. This brings the range of the advantage. GPU accelerations for large models. For large models also with complex layers, such as deep neural networks (DNNs). GPUs significantly accelerate computations due to their parallel processing capability and processing capacity. Scalability. The transitioning between different hardware platforms allow ONX runtime to achieve optimal performance in any environment, from personal computers to cloud or embedded device.
3. Runtime optimization. During runtime, ONX runtime continue to optimize by adjusting the computation schedule to fit the current hardware structure. This includes parallel execution. This automatically dividing large computation operation into smaller parts, executing them in parallel across multiple CPU core or CPU paths. Scheduling, organizing the order of operations to avoid unnecessary waiting and optimize resource use, helping to prevent bottleneck and increase execution speed. Caching, optimizing the storage of intermediate result to minimize memory access or recomputation of regularly executed operation. 4. Dynamic conversion between precision modes.
ONX runtime can automatically select the most suitable precision mode for each model, including swing precision flows. High precision mode but requires significant resource. High precision flows eager to reduce memory cost and speed up computations while maintaining acceptable accuracy. At this interval, either for models that require high resource optimization without needing to mark precision, helping to reduce mode size and increase execution speed.
5. Minimizing memory cost and efficient resource management. So with memory sharing, ONX runtime employ memory sharing techniques between computation stacks to minimize memory cost. It is particularly important for large models or resource-constrained environments such as embedded device. With model size reduction, it is very important because utilizing model compression methods such as using empty integer to decrease model size without significantly compromising accuracy. Dynamic resource management. It has the capability to manage resource dynamically, automatically freeing unnecessary memory when related operations are completed. As a result, after converting the original Python full precision float to model to ONX full precision float format, the model size was almost the same as expected, and you can see. Then we apply the respective empty integer quantization process on both models. The result is ONX runtime was able to quantize more layers and reduce model size almost 4 times, during a model around half as large as the quantized Python model.
6. Cross-framework and format compatibility. Since ONX is an open model format, it can convert models from various machine learning frameworks such as PyTorch, TensorFlow, scikit-learn, and etc. This allows developers to easily import models to the ONX format and leverage ONX runtime for its execution speed up, rather than having to optimize each framework individually. 7. Continuous updates and community support. ONX runtime is an open source project continuously developed by Microsoft and the community. Regular updates provide new optimization, hardware support, and new features. This ensures ONX runtime remains in optimal condition regarding performance and compatibility.
So, in conclusion, ONX runtime stands out as a powerful solution for enhancing the deployment and execution of deep learning models across diverse frameworks. So, its robust optimization technique support for various hardware accelerators and dynamic resource management continue to significant performance improvement. Furthermore, its compatibility with multiple frameworks and continuous update from the community. ONX runtime remains at the forefront of machine learning advancement. By decreasing ONX runtime, developers can streamline their workflows, achieve greater efficiency, and deliver high-performance model in a rapidly evolving technological landscape. And that's all my presentation about the ONX runtime engine. Thanks for listening.